In this demo, I have a CM510. Let me turn it on. It's designed as a car bot. So this is servo 1, this is servo 3. They're all AX12A. And this program is X12 position.tskx. So you should have that with the book also. So in this program, the first command is this one. So it's a load command. Essentially, it takes 1023, a value of 1023. It save it into address 8 and the ID 254. That means all servo, mean 1, 2, 3, 4 on this bot. And then the next command I tell for 1, I tell it, oh, why don't you go to 200? And for 3, I tell it to go to 800. Okay, so 3 right now is somewhere, and 1 is right now somewhere. The arrow kind of point to where it should be. And then the command was to print line with 0, and then print out the present position for 1, and then print out present position for 3. Essentially, this is if you are just new with programming and robotics, and you're programming normally in your other program where you don't deal with hardware. One would think that, oh, if I send a command for 1 to go to 200 and a command for 3 to go to 800, when I print out the position here, I expect it to print out somewhere close to 200 and somewhere to 800, right? Because normally that you assume if you are programming regular code on a PC. But so let's see what it does. So make sure I have it on. Oh, also very important, I wrote my code for a CM510. So if you happen to be using another piece of another controller, you need to make sure you change it to the right one, okay? And then, of course, make sure to the right COM port. So I have COM3 in this particular case. So let's download the program. We recorded, no error. Let's view output of the program. Okay. So I'm on play mode. It's blinking now. I'm going to push play. Okay. So you notice is whatever it was, it's trying to go to 200 and 800. So this is happened to be 200 for 1 now, and this position happened to be 800 for 3, or close to it. We'll see how close. But the thing is, when it printed out 0 and then go to new line. So it printed out 456 and 3 was bringing 231. So this was actually whatever position they were on before this program will really run. Okay, so it's 456 and 231. The reason is the computer is very fast. So when you send a command, usually you have to wait until you get there before you print out the present position. Okay, so let's just run it again now. You can see, let's see if I can run it again. Here we go, it run again. Now it shows 200 and 800, and you see it didn't move anything. So it did go to 200 and 800 correctly, but depending how you program, the data that you're printing out may not be what you want, or it actually show out the correct data. It just your logic was faulty. So one thing we can do to go back and enable this number 10, and what it does is this is a wait while command, where essentially say as long as servo number 1 is moving, that means it's flag, the moving flag is true, or servo 3 is moving, that means its moving flag is also true. When either of them are moving, it's okay, don't do anything there. So it just wait here doing nothing. So the command will be, it's gonna go wherever they are. Let's see, let me turn them off. So I can just put it whatever I want to. Turn it back on again. So it's not at 200, 800 anymore, it's somewhere. And when I run, this one is gonna be different. If it tell the command to go, you can see the servo moving. but then it's sit here as long as it's moving. That means they haven't reached a goal position yet. It will wait here, and then only when it gets to their position 200 and 800, and then start printing. You're gonna see it's gonna print better close to 200 and 800 this time around. Okay, I got everything going. So I download again. Your output of program. Now I can run. It's moving. You can see that show 200 and 800 as it should be. Okay, so I'm going to pause a little bit, bring in some other code, and we'll continue on with this demo. Okay, so I'm back, and this is a code for AX12 move no hold. Check again, CM510 COM3. In this piece of code, I want the single servo 1 move back and forth only. Also, I'm going to move at full speed, so this is a new load command. Put 1023, that maximum speed, into servo 1, which is this one here. So also introduce a new structure, endless loop. That means everything inside will be keep on being repeated. Therefore, we're going to do something called move 1, called move 2. So call these are functions, which basically independent piece of code that you can set up outside of the main. So see, this is a start program. It's a main piece of code. Function, you had defined it after the main code. And what function move 1 was just to send servo 1 to position 205 and then print with line 1 just to show that it's went through the move 1 really or anything. And then you had a return command, so it come back to this position here in the main program. And then it will call move 2. That means the computer, the controller will jump to this position, statement 19 here, go in here, and tell the goal position to go to A19, print out 2, and then return, and then come back here. And then because endless loop, it keep on repeating like that. Okay, I'm ready to go. So let me check, power on, and I'm going to download it. There is no error. It download okay. Your output program here. I'm in play mode. I'm going to put the play button. And then you notice interesting. First you see 1 2 1 2 1 2 endless loop. So it shows that it did go through function 1, function 2, and print it out 1 2 1 2. But this is not going to 205 and then to 800 or anything. It's just jiggle jiggle where it was, and it kind of at random there. So what is really going on? Same thing again. It's because the computer is so fast. Let me stop this. So let me terminate the program. So it went. I turn it off. So the computer trying to go to tell it to go 205, and then because you didn't have any wait line here, it is done, and then jump to call move 2. It moved to the A19. So essentially, this one tells to go 205 and 819. So you tell so fast, I didn't get a chance to move to the right places. That's all. Okay. So learn again. If you're dealing with robots and moving servo or moving motor, usually you have to think about, oh, if you tell to command to do something, usually you have to wait until you get there or when the command is finished. You cannot just ask it to do too many fast things. So I'm going to pause again, get some other new code in. So this new piece of code, AX12 move margin. In here, first, every time that the function, we still have the call move 1 and call move 2 in the endless loop again. But now, after we tell to go to position, to certain goal position, we call a hold function. Same thing for move 2, there's a call hold function. And what hold function does is all it just have that wait command. Wait as long as the servo 1 is moving or the moving flag is true, just don't do anything. So essentially in regular life, it means, oh, go to 2005 and then just wait until you get there. And when you get there, it's going to print out the present position. And get there, print out the present position for when it's trying to go to 819 here. So you should see a line that is close to 205, a number close to 205, and then the next to it is a number close to 819. The question will be how close, depending on the so-called margin. And if you remember in the book, if it's your goal position, B and C are called margin. And the margin is a position where you kind of cut power to coast into your position, a goal position. So there is a counterclockwise and a clockwise approaches B and C. So they don't have to be symmetrical. Usually we do it symmetrical, but it doesn't have to. So if we go back here, you see that clockwise margin. That means when it's going toward somewhere in a clockwise direction, that means like this. That means usually toward the smaller position of the servo. And then it's 10, so it's pretty big. Counterclockwise margin is 0, so very tight. So we'll see how it behave here, and you look at the present position when this code is run. Okay, check again. Power is on. It's ready. So, margin here. Okay, let's download it. Your output program. I'm making it run now. So number one, we'll go back and forth. Okay. So it's gonna bounce around between 205 and 819. So 205 is about there, and 819 is about there. So it's supposed to go to 205, but it really goes to 197, and 819 does really go only to about 814. Okay. So this one, what? 197, 188, that's 6 units. This is about 5 units. Okay. Let me stop that. And let's try to run this again. It just have margin of 1. And this one have margin of 1 also. Let's see if anything much changes. It's ready again. So ready to run again. Okay. So first one is that. So 203, 205, things are much tighter. And 819, 815. So get 8 to 15, 819 are kind of tougher, but the one in the lower end seem to work better, closer here. Okay, I'm going to pause again, and we'll get some new code to show you. Okay, I'm back. And this one here, X12 moves smooth. So this one here is we're introducing the new concept of slope. So we have the margin 1. That means that's the best you can do. I mean, that's more accurate. We have going full speed. The slope is either A or B. That means that the limit when you start slowing down, you start dropping your current or your power linearly down. So it's D and A here. So this one in 32, this 0, 1 here, it's just binary. It really meant also 32. It just happened to be binary. And then we have the main endless loop, move 1, move 2 again. So it's still position 205, hold it, print out the present position, A19, hold it, print out the present position. Okay, so let's see what this looks like when you actually run it. It's ready to go again. So I'm going to download. Okay, your output of program. And let's run it. Okay, so want to move back and forth again. 203, 204, 19, not making much difference because it was happened to be the slope happened to be kind of 32 by default value already. So this is no different from than the previous program. Okay, so because it was already 32 default. So let that change it real small. So I'm going to change it to like about 15. This here, I'm going to change it to 15 also. So 15 has to be 111 here, kind of neat, huh? Okay, so what it does is when you make this so-called slope DOA value real small, it means what? The servo going to go full blast at full speed. And when they get closer, that means instead of 32 distant here for D, it's only get to about 15 when it starts slowing down. So this is kind of equivalent to people who drive fast and wait until the very last minute when they get to the red light and stomp on the brake. And you know what happened, right? And then we'll see. So we have 15 here. Download. Here we go. And run again. So if you notice, I don't know if you can see in the video, but it's not very smooth at the end point where it breaks down. You see it's shaking a little bit. You see you probably should see the arrow kind of jiggle instead of going smoothly and kind of get into it. Okay, so this is 16. It get closer to 819, 205, 206. So you have that. So you do get this position better. You see it's shaking a lot. So let me stop that. And let me go in and let's say let me change it to like a real big slope. So let's say 50. And make this one also 50. So that means this servo start breaking from very far, much further away. So we're ready here. Let's go down. Let's run it. Okay, I don't know you see in video, but when it goes, it stopped there. It's just you don't see the arrow jiggling. It stay pretty firmly and go back, stay firmly going back. Okay. So when you design your robot, especially like a humanoid walking, you need to be careful how to set up margin and slope to make it real smooth, so your bot doesn't shake when it's stopping. Okay. So I'm gonna pause again. Okay, so I'm back. This is the code AX12 monitor position speed. This piece of code essentially trying to show you how to create a data acquisition loop. So you're going to use a controller to study in the detail what's going on. Okay, and essentially we're going to do is we're going to monitor the speed and the position of this servo number 1 as we tell to do something. So what we're doing to do to it. So first, first we set up velocity to 1,000, which is very fast, and we tell to go to goal position 0. So this is our initial position of our experiment. And then we just wait a while, make sure you have time to get to goal position 0. And then just to clear out our data screen, so I print 0. And then I change the velocity now to 200, so it's going to go slow. And I tell to go to 512. So at this point here, you have to remember it's already supposedly at position 0, and we tell to go to position 512, but at pretty slow speed. And then as you collect data, you have to collect with time. So there must be a way to tell you how time it is, how far it was away from the initial time 0, shall we say. We don't have time 0 in the controller. The only thing you can do is you start a timer, like a countdown stopwatch at 100, and then it will count down every unit So every time it count down to, let's say, 99, it means 1/8 of the second has elapsed of real time or close to it. Okay, so we start the timer, the countdown at 100, and then immediately try to print 111 so that I know which just one of my data line. I print out the timer that time, so the computer is pretty fast, so it should print like it's still 100 pretty much, because 1/8, this command here doesn't take 1/8 of a second to execute. Okay, so it should show, so timer here immediately had to show 100, and then the present position will print out the present position, present velocity, and then what I do is whatever the timer is, I save to a new variable called timer1. And then I have a big loop here. In this loop, what it does, it say, oh, execute this big loop, which is all the way from here to here. And the loop say, as long as ID server 1 is moving, go ahead and keep on doing whatever is this loop you're supposed to do. So first thing it goes into this loop is it take whatever the timer is, that means 100, 99, 98, or whatever, save it into another variable of timer. And then remember the timer, I got it outside the main loop here. I say, oh, timer minus timer2, you get a delta time. Okay, and then that delta time, if timer 1 and timer 2 are the same, that means it just start doing it, the subtraction will become 0. So delta time could be either 0 or essentially probably 1. Okay, and then this piece of code is an if statement. That is a group here. If delta time greater than 0, that means the timer count has changed by 1 at least. Okay, because 1 will trigger it. It print out 222. It print out the timer value there. It print out the present position of ID1. Print the present velocity, and then at the reset, that timer variable to whatever it is now. Okay, and then it finished this one. It loop back. It pick up the timer and say time 2 again, because this one it would do very fast. So the delta time will be 0 probably next time right away. So if 0 is no bigger than 0, it probably skip this. It won't print in the loop again. So essentially, this if statement here allows this group of statement only to print whenever the timer actually changed by 1 count. Okay, so you keep on doing that. Eventually, it's not moving anymore, and then it's gonna get out. So it's not moving anymore. It could print out the data for the last time. I have 3 to tell me that the last time. It print out timer. That this spot here should print out 0, and then whatever the present position is and present velocity at that time. Okay, so let's see how it does. Okay, you're ready. I'm going to download it. We'll output the program. Push it run. We're going to go fast first to position 0 right there, and then going slowly, and then we can see. So it goes pretty fast here, but luckily we have this data acquisition loop to capture all data. So you remember the way it print out is it print out 0 first right here, right? Okay, and then it print 111, the timer, you see it's still 100. Present position at that time should still be 0, and start picking up the speed a little bit, so that's 4. So next time around, you see it print 222, break it inside that main loop. You see it's 99, timer count. You see 98, 97, 96, 95. You see it's only changed by 1 throughout the main loop. And it's at time you see 222, that in the main loop. You see it go to position 1. Look at the speed. The speed is start picking up to 100. So it's already at position 50. 212 at position 105. It starts slowing down a little bit, so the speed does fluctuate a little bit. So the position is 160, 216, and so on. 484, 212. And then at the spot here, because it got to 513, that means we are supposed to go 512. So go over a little bit, so it starts slowing down. Okay, and then it's not moving anymore at this spot because it's reached 512, so it stopped, and then it print out the last time, which is 333. So at that time, you can see that the timer counter is 88. It arrived at 512. This speed here, 1028, doesn't mean it's going very fast. When any number is more than 1023, it really means it's going the other way. Okay, So basically the controller inside the motor notice, hey, I'm past 512 where I'm supposed to go, so I better reverse the velocity. That means I'm better going the other way. So 1023, I mean 1028 here mean minus, so it minus what? Minus 5 going the other way. So it's like 5 minus 5 instead of plus 4 here. So this is going to minus 5.